Hi everyone, welcome to Homeschooling Digital SAT Prep channel. Today we are going to start a new chapter in mathematics. The name of the chapter is Right Triangle and Trigonometry. In this chapter, we are going to have two videos, each video consisting of 10 to 15 questions. In first part, we will cover the basics along with questions of low and medium difficulty level. In second part, we are going to cover high difficulty level questions along with previous year's questions asked in SAT examination. I'm going to comprehensively cover different types of questions possible from this chapter from various SAT books. One thing I can make sure that even though you have never read this chapter before, after sincerely watching all the videos in this chapter, you would be able to solve any question related to this chapter asked in future SAT examination. One more thing that I would like to tell you that trigonometry is a very vast chapter. Here we will restrict trigonometry and its correlationship with right triangles only. So I want you to take out your notebook and pen and start solving these questions along with me. So let's go. So this is your syllabus here, and and as we can see that this is geometry and trigonometry, and we have a chapter named as right triangles and trigonometry. Here, most of the time we get only one question. Very rarely two questions have been asked from this chapter, but most of the time only one question has been asked from this chapter. Now moving to the basics. So this is our Pythagoras theorem in basics. As we have learned in early school days that if there is a right triangle like this is your right triangle. The side opposite to the right angle is called hypotenuse. Hypotenuse. So this is your triangle named as ABC. So as per the Pythagoras theorem, we have read that the square of hypotenuse would be equal to the square of other two sides. That would be AB square plus BC square. And if we have to find AC, we can find it by taking under root on the other side, and AB square plus BC square. So this is the way in which we most of us have learned Pythagoras theorem in this way. But if I tell you that this is not the correct representation of Pythagoras theorem, Pythagoras theorem is not about the square of the sides. It's about the area of square. Let me show you what I'm trying to say. So this is your right triangle here, and if we draw square on all the three sides, this is your hypotenuse. So if you draw a square on the hypotenuse, so its area would be how much? Because one side is C, so the area would be C square. Similarly on other two sides, so this side the length is B, so the area would be B square. And if we draw on this side a square on this side of the triangle, then its area would be how much? A square. So as per the Pythagoras theorem, in a right triangle, the area of the square area of the square whose side is hypotenuse is equal to the sum of the area of the square. Means this square area would be equal to the area of these two square, sum of area of these two square. So this would be C square, that is area of this square would be equal to sum of the area of other two side square, area of other two squares. That would be A square plus B square. So this is your correct representation of Pythagoras theorem. Even when I went to college, one of my friend taught me during my engineering days. He taught me that this is not the correct representation. This one is the correct representation of Pythagoras theorem. One more thing about the history about the Pythagoras theorem, that this Greek mathematician named as Pythagoras, he was not the first one to who knew about this theorem or this Pythagoras theorem. There are few more people. I'm from India. There was a mathematician named as Bodhyana. I think somewhat around 800 BC. He wrote a text named as Sulb Sutras. Sulb Sutras. So you can find this theorem there also. There was one more book named as Surya Siddhanta. Surya Siddhanta. It was around 400, 500 AD. This text was written in. So it is about Surya means sun, and its position with various planets. So it was a book about astronomy. Astronomy. There are few more like I'm unable to recall that ancient Egyptian mathematician name. So there is one more ancient Egyptian mathematician who also who also knew about this theorem before. So yes, the, this is not your correct form of Pythagoras theorem. This is not your correct representation of Pythagoras theorem. This is the correct representation of modern Pythagoras theorem that we read right now. So if anyone asks you what is Pythagoras theorem, you don't have to tell that it is the square of the sides. No, it is the area of the square whose side is hypotenuse is equal to the sum of the area of squares whose sides are the two legs. So this square area would be equal to the sum of these two squares. So this is the correct representation of Pythagoras theorem. So now coming to the trigonometric functions. This is your right triangle here, as we know, and it is a right triangle at angle C. So the opposite to the side opposite to the right triangle would be called as hypotenuse. Okay. Now if we take an angle A here, so what we are going to call the side adjacent to this angle A would be called as adjacent side. If we take this angle A, then this would be called as adjacent to the side of angle A. Then AC would be your adjacent. And the side that is opposite to this angle is called as opposite side to the angle A. So you have to remember this before we move on to the trigonometric function. So we have six types of trigonometric function: sine, cos, tan, and cosec, sec, and cot. So to remember the formula of these trigonometric function, you have to remember this. So ka to a. So sine A. So S stands for sine, and if we take this angle, any angle, we can take this angle or any angle. So sine A. So we will use this. So sine is equal to O stands for opposite and H stands for hypotenuse. So sine A would be opposite. So opposite by hypotenuse. So sine A would be opposite, that is BC, by hypotenuse, that is AB. Now for cos K. So A stands for adjacent and H stands for hypotenuse. So adjacent by hypotenuse. So cos A would be adjacent, that is AC, this length of AC, and hypotenuse is AB. Similarly for tan, TOA, this part TOA. So for T would be tan here, and O would be opposite, and A would be adjacent. So for tan A would be what? Opposite, that is BC, BC by adjacent, that is AC. So this would be BC by AC. And as we know, the length of BC is taken here as A unit, and this is B. So this is how we can remember. Most of the questions are asked from sine, cos, and tan, but there are three more trigonometric function. So cosec is inverse of sine. So that would be, cosec would be inverse of sine, that is hypotenuse by opposite. Hypotenuse by opposite. Similarly, sec is opposite of cos. So that would be hypotenuse by adjacent. That would be hypotenuse by adjacent. And cot would be adjacent by opposite, because it is, cot is opposite of, sorry, inverse of tan. So it would be adjacent by opposite. So this is the way by which you can remember the formulas of trigonometric function. So for sine, where S stands for sine, O stands for opposite, and H stands for hypotenuse. Similarly, Ka is cos, C stands for cos, A stands for adjacent, and divided by hypotenuse. Similarly, Toa, tan stands for opposite by adjacent. And cosec is inverse of sine, sec is inverse of cos, and cot is inverse of tan. So these are the formulas for the for the trigonometric function. Now let's take one more example here. So this is your right triangle here, similar to this, A, B, C. So here we have sine A. So sine A is opposite by hypotenuse. So that would be BC, opposite, that is BC. Hypotenuse is how much? AB. AB. Or we can also say that the value of BC is A, and AB value is C. So this is for sine A. What would happen if we take sine B? So for sine B would be, so that would be opposite by hypotenuse. So opposite of angle B is what? AC. That would be AC, and hypotenuse is AB. And hypotenuse is AB. So for with respect to angle B, this side would be adjacent, BC would be adjacent, AC would be opposite to the angle B, and this one would be your hypotenuse. So you have to remember that. You have to see what is the angle with respect to the trigonometric function is given. So these are 6 trigonometric functions we have learned. Now, sometime we would in question these two, the length of these two sides would be given, and you have to find what is the angle of the right triangle, one of the angle of the right triangle. So as we know, from so sine A is equal to, so is O for opposite by hypotenuse, or sine A or sine theta, whatever you want to. So if angle, we can take sine on that side, so it would be sine of opposite by hypotenuse. So we can find the angle by because nowadays Desmos scientific calculator is provided, so we can put sine inverse and what is the value of opposite by hypotenuse, and we can find the value of the angle here. So for inverse functions like this, sine inverse of opposite by hypotenuse is theta. Similarly, cos inverse of adjacent by hypotenuse is also equal to theta, and tan inverse opposite by adjacent is equal to theta. So we have derived these inverse function from these three functions. So these are this thing is about your trigonometric functions, about 6 trigonometric functions. Always remember what is your angle provided. If it is A, then take adjacent, then this would be your adjacent, this would be your opposite. If you take B, then this would be your adjacent, this would be your opposite. So always remember, always focus what is the angle provided in the question. So now after trigonometric function, now there are a set of few co-functions. So in co-function, let's see sine. Let's take this the value of this is A, B, and C, and here this is angle A and this is angle B. So if we take sine A, if you put sine A here, that would be opposite by hypotenuse. The, that that would be A by C. Okay, A by C. Similarly, cos B, cos B. So we will use this formula ka, that is adjacent, that is BC, that would be A, and hypotenuse, that would be C. So as we can see, sine A and cos B, the value are similar. So so these are uh, if sine A is equal to cos B, then they are called as co-functions, because triangle is a right triangle, and if a triangle is a right triangle here, then the sum of other two angles would be equal to how much? 90 degree. So you have to remember, if sine A is equal to cos B, then these two angles sum would be how much? The angle of sum of the angles would be 90 degree. So if sine A is equal to cos B, then angle A plus angle B is sum would be 90 degree. Similarly, we have two more co-function. Cosec angle A is equal to secant of angle B, then angle A plus angle B would be 90 degree. If tan A is equal to tan B, cot B, then angle A plus angle B is equal to 90 degree. Mostly the question is asked from this co-function, but you have to remember these two co-functions also. Similarly, inverse of that is also correct, that if angle A plus angle B is in a right triangle, angle A plus angle B is 90 degree, then sine A is equal to cos B. If angle A plus angle B, inverse of this would be, if angle A plus angle B is 90 degree, then secant of angle A would be equal to cosecant of angle A would be equal to secant of angle B. Similarly, for this, tan of angle A is equal to cot of angle B. So mostly questions are asked from this one, but you have to remember uh, these two other co-function as well. Now moving to the next concept here, you will find a lot of questions that are asked in SAT exam. You will find the angle in the right triangle. You will find these angles very common. That is, what in a right triangle, 30, 60, and 90, and a combination of 40, 45, 45, 45, and 90. So there are formulas for it which you can remember. So if in a triangle, if in a right triangle, if one side in a right triangle, if one angle is 30 degree and the other angle is 60 degree, then we take the side opposite to 30 degree as S. and the side opposite to 90 degree as 2s, and side opposite to 60 degree as s root 3. So how it will come handy in your examination? So if one of the side is known to you, and this is your figure 90 degree, 30, 60, and if one of the side is known to you, like let's say this is 10, so you don't have to go through all the formulas of sine, cos, tan, and you can, so from if you know one of the three sides, you can easily find what is s, and now you can find other two sides as well. So if this is your right triangle with 30, 60, and 90, and if we know that side opposite to 30 is what, 10, so what would be the side opposite to this? If this is s, that is 10, then this would be twice of s, so 2 into 10, that is 20. Similarly, the side opposite to 60 degree would be s root 3, that would be s is 10, so the answer would be 10 root 3. So this is a way to solve question in very less time. It will come very handy in your examination. Similarly, if a right triangle is there and one angle is 90 degree and the two angles are 45 degree, so sides of opposite to the 45 degree would be considered as s and s. As you can see, this is 45 degree, so opposite to this angle the side would be s, and this is 45 degree, so the opposite to side opposite to this angle 45 degree would be s, and opposite to 90 degree would be s root 2. So if we, in the question, a figure is given and we have three angles of 90, 45, 45, and hypotenuse is given as 10 root 2. So from this we can say that s is equal to 10. So we can say that this side is 10 and this side is 10. So let me give you one more question here. So this is your triangle here, okay, and hypotenuse is 10. So what are going to be the other sides here? So as we know, hypotenuse is 2s, so 2s is equal to 10, so s would be 10 divided by 2, that would be 5. So this side would be 5 and this side would be 5 root 3. So instead of going through conventional way, if you remember these tricks, it will come very handy. So please remember these two tricks of 30, 60, 90 degree triangle and 45, 45 and 90 degree triangle. This will come very handy. There are few ratios, or the we can call it as triplets. So if two sides are, if 3 and 4 are the two sides, then if you use Pythagoras theorem, then the third side would be 5. If this is 3, this is 4, then your hypotenuse would be 5. Similarly, 5, 12, if two sides are 5 and 12, then hypotenuse would be 13. A lot of questions have been asked in SAT examination where two sides are already given. So excuse me, instead of going through finding the hypotenuse using Pythagoras theorem, you can remember these ratios. It will come handy in examination. Now moving to the next concept. If one of the trigonometric ratio of an acute angle is known, then the remaining trigonometric ratios can be easily determined. That's it. It says that if this is your right triangle and if this is A, B, and C. So if we know sine A, that is opposite by hypotenuse, that would be BC by AB. So if we know the ratios of any ratio of acute trigonometric ratio of, so like if we know the value of any two sides like BC, AB, then we can find the other trigonometric ratios. So we should know at least two sides of a right triangle. Like if we know AC and BC, then we can find AB by using Pythagoras theorem, and we can, through that we can find all the trigonometric ratios of the angle. Similarly, the values of trigonometric ratios for angle 30, 60, 40, 40, so 45, 60, and 90 should be known to you. Previously, there were two sections in mathematics. In one section, calculator was provided, and in one section, calculator was not provided. So in in non-calculator section, if for that you have to remember sine cos 10 of 0 degree, 30 degree, 45, 60, and 90 degree. But now calculator is provided for all the questions, so now we don't need to remember this. We will we will take this ratios in next slide. Then complementary rule. Sine x is equal to cos 90 minus x. So like if we know sine x is 30, then what is cos? Cos would be 90 minus x, that is 90 minus 30, that would be 60 degree. Similarly, we know cos 45 degree, then what would be the sine? Sine would be 90 minus x, that is 45 degree. So 90 minus 45 is 45 degree. And so we have to remember these two complementary rules, that sine x is equal to cos 90 minus x and cos x is equal to sine 90 minus x. Very rarely questions are asked from complementary rule. There was one question like sine x is 4 by 5. So what is cos 90 minus x? So as we know from this complementary rule, that sine x is equal to cos 90 minus x. So cos 90 minus x would be also equal to 4 by 5. As from complementary rule, these two are equal to each other. Now we have a few more formulas here. Sine square a plus cos square a is equal to 1. Similarly, for secant tan, sec square a minus tan square a is equal to 1. And similarly, cosecant square a minus cot square a is equal to 1. So you have to remember these formulas. And there's one more formula, that sine a by cos a is equal to tan a. So this is also a very important formula. So you have to remember, you might need these formulas in very rarely questions are asked from these formula, but I want you to remember these four formulas as well. And this complementary rule formula is very important. Now moving to the next slide. So these are the trigonometric ratio. Previously calculator was not provided for these trigonometric ratios, but now calculator is provided for all the questions. So there's no need to remember this, but I want to show you a trick. If you are interested to remember these trigonometric function, then do watch it, or you can skip this slide and go to the question. So if you want to remember these 0, 30, 45, 60, and 90 degree of sine cos 10, so I'll show you a trick how to remember these. This is how I learned in my school days. You will take under root, and we have a numerator and a denominator like this and like this. And top we will start with 0, 1, 2, 3, 4, and we will divide all of them by 4, 4, 4, 4, and 4. So 0 divided by 4 would be 0. If we divide it by this, so 1 by 2. Sorry, 1 by 4. Sorry, 1 by 4. So under root 1 would be 1 and under root 4 would be 2. So this will be 1 by 2. Similarly, if we cancel these two, this would be 1 and 2. So under root 1 would be 1 and under root 2 would be under root 2. So 45 would be 1 divided by under root 2. Similarly, under root 3 would be 3 under root 3 and under root 4 would be equal to 2. So sine of 60 degree would be 3 by under root 3 by 2. And similarly for 90 degree, so under root 1 would be equal to 1. As we know the complementary rule that cos theta is equal to sine 90 minus theta. So cos 0 degree would be, if you put 0 here, then this would be sine 90. So yeah, as you can see, sine 90 and cos 0 are equal. Similarly, if we take cos 30, if we put theta as 30, then sine would be, that would be equal to sine 90 minus 30, that is sine 60. So as you can see, sine 60 and cos 30 are equal because of this complementary rule. Similarly, 45, then sine 45 minus 4, sine 90 minus 45, that would be sine 45. So these two would be equal. Similarly, cos 60 would be equal to sine 30 and cos 90 would be equal to sine 0 degree. And for tan, you have to remember this 0, 1 divided by, you have to 0 and 90 would be 0 would be 0, 90 would be non-defined. This 30 would be 1 divided by root 3. 45 would be the numerator of 30 and 60 would be the denominator of that. So from this you can remember 0, 30, 45, 60 and 90 of these trigonometric functions, sine, cos and tan. And if and as we know, cosec is opposite of what? Sine. So something divided by 0 is not defined. Similarly, uh, cosec 30 would be inverse of sine 30, that is 2. And then cosec 45 would be inverse of sine 45, that is 2. Similarly, like this secant is opposite to cos. So as you can see, secant 30 degree is opposite of cos 30 degree, inverse of cos, that would be 3 root 2, the inverse would be 2 divided by root 3. Similarly, tan and cot are opposite to each other. So tan and cot are opposite to each other. So as you can see, cot 30 would be inverse of tan 30. So this is how you can remember these trigonometric ratios if if calculator is not provided in the examination or the ratios are not given in the examination. Now we are going to learn about various trigonometric ratio and are their values going to be positive or negative in various quadrants. So this is your first quadrant, 0 to 90 degree, or in radians you can call it 0 to pi by 2. Then this is your second quadrant, from 90 to 180 degree, on radian pi by 2 to pi. This is your third quadrant, 180 to 270 degree, or in radian you can call it pi to 3 by 2 pi. And this is your fourth quadrant, from 270 to 360 degree. So there is, you have to remember this, all student take calculus. All student take calculus. So for, we will take A from the all in the first quadrant, S student, S from the student in for the second quadrant, take T for the third quadrant, and from calculus we will take C for the fourth quadrant. So this means all trigonometric ratios are positive. In second quadrant, S is there, so only sine is positive in second quadrant, and rest all the trigonometric ratios are negative in second quadrant. Then third quadrant T, that means only tan is positive. Here A for all, S for sine, only sine is positive. Third, only tan is positive. And for fourth quadrant C, that would be cos is only positive. So now let me ask you, if sine if we know that sine 40 is there, so it will be positive or negative. So 140 would be in second quadrant because it is between 90 to 180 degree. So f- this would be in second quadrant, and in second quadrant sine is always positive, hence this will be positive. Now n- sine 190 degree, so 190 degree comes in your third quadrant, only tan is positive, so the sine would be sine 190 would be negative. Similarly, if you take tan 235, so 235 comes in third quadrant and only tan is positive, so the value of tan 235 would be positive. Then in, then cos 290 degree, so 290 comes in the fourth quadrant, and in fourth quadrant only cos is positive, so cos would be positive, sorry, positive in fourth quadrant. In question number 1, it is given that in right triangle one of the angle is x degree. If tan x is 5 by 12, what is the value of sin x? In this question, diagram is not given, so in the question it is only given there is a right triangle. So let's draw a right triangle here. So let's draw a right triangle. So as we have read in the basics, so ka toa. So for tan, so ka toa. So as we have, this is going to be 90 degree. So we can take one of the angle. Either we can take this angle or this angle. Any angle, answer would be same. So let's take this angle as x degree in this right triangle. So in the question it is given that tan x is equal to 5 by 12. As we know, TOA is equal to opposite by adjacent. So let's take this as A, B, and C. And we have taken this angle. You can take this angle or this, whatever angle you will take, answer would be same. And we know that this is a right triangle, so this would be this angle would be 90 degree. So opposite, if we take this one, see angle x here, so opposite of that would be AB. So opposite by adjacent, and adjacent to this angle x is BC, that is 5 by 12. From this we can say that AB is 5 and BC is 12. So this is a right triangle. So by using Pythagoras Pythagorean theorem, Pythag theorem, we can say that AC square is equal to AB square plus BC square. BC square. So AC would be AB square, that is that would be 25 plus BC square 12 square, that would be 144. So if we add both of them, that would be 169. So if we take root out it, then AC would be 13. So AC would be 13. In question, it is said that what is the value of sine x? Sine x. So as we know that's sine, so katoa, so sine x is equal to opposite by hypotenuse. So opposite is 5. This angle opposite is 5 and hypotenuse AC, that is 13. So sine x would be 5 by 13. So this is going to be your answer B. Now moving to the next question. John needs to measure the height of a building near his house. He chooses a point P. This is your point P on the ground where he can visually align the roof of his car to the you can visually align the roof of his car with the edge of the building roof. So he can align roof of his car with the building's roof like this. The height of the car is 4 feet. So if this is PQR, let's take this as S and T. If height of the car is 4 feet, that means SQ would be 4, and the distance from point P to Q is 10 feet. P to Q is 10 feet. Distance between Q and R is 80 feet. Q and R is 80 feet. So the whole distance would be 90. This PR would be 90. And height of the building is K feet. So this RT would be K. So we have to find what is the value of K. So in this, we have two triangles here. Triangle, this is the smaller one, PSQ. Triangle PSQ, and triangle, the bigger triangle PTR. Triangle PTR. First, we have to see that these two triangles are congruent or similar triangles or not. So there are three ways to find that both the triangles are similar or congruent. There are three ways. Either all the three sides should be equal, either two angles should be equal, or either two sides and one angle should be equal. So if we consider these two triangles, PSQ and the bigger triangle PTR, so as we can see, this angle is common, one angle is common, and this angle and this angle SQP, this angle and this angle is similar. So we can say that hence both the triangles are congruent, hence their sides will be in equal proportion. We have read this proportion. We have read this in triangles chapter, in the basics of triangles chapter. So we can take that QS in smaller triangle, QS by PQ is equal to, so QS is this one, so we'll take this one, RT, or we, as in the question it is given, it is K by base, if PQ. So for the bigger triangle, the base would be PR. So now let's put them one by one. QS is 4, PQ is 10, RT, in the question it is given as K feet. So I'll keep that as K feet, and PR 10 plus 80, that would be 90. So this will go 9 times here. Hence, K would be 9 into 30, 9 into 4, that would be 36. 4, that would be 36. I don't know why there is no option here. I think options are not correct here. I have to please, I think I have kept the option of some other question here. So the correct answer would be 36. These options are wrong. The correct answer would be 36. 6. Now moving to the next question. In question number 3, right triangle ABC. So let's draw a right triangle which is right angled at A. So if this angle, then this would be B and C. If BC is 10, if BC is 10 and angle C is 30 degree, angle C is 30 degree, what is the approx perimeter of triangle ABC? So there are two ways to find the answer of this question. First, we will go with the traditional method, which consumes slightly more time. So as we know, so katoa. So if we take sine 30, so that would be opposite, that would be AB by hypotenuse, that would be BC 10. As we know, sine 30 is half. So AB would be 5. AB would be 5. Excuse me. Excuse me. And so by using Pythagoras theorem, we can find AC. So AC would be under root 10 square, that would be 100 minus 25. So that would be under root 75. So that would be equal to 5 root 3. So this is your traditional method to find all the sides ABC. Now we can calculate perimeter by adding all the sides. So this is 5 root 3. So perimeter would be, if we add this, 5 under root 3 would be somewhat around how much? Let me calculate. 5 into 1.73. That is going to be around 8.5, 8.6. So 10 plus 5, 15. 10 plus 5 plus 8.6. So your answer would be 23.6. So D would be answer. So this is your traditional method and it consumes slightly more time. Now, as we have read something in the basics, there were two triangles and this was 30 degree. As we know, this is 30 degree and this is 90 degree. And in the question, these things are provided. As we know that this is 90 degree, this is 30 degree, and sum of all the angles is how much? 180 degree. So this angle would be 60 degree. As we have read in the basics that if any triangle has an angle 90, 30, and 60, so opposite to 30 would be S. Okay. And opposite to 90 would be how much? 2S. And opposite to 60 would be S under root 3. So as we already know, BC is 2S. So 2S is 10, then S would be 5. So then BA would be 5 and S root 3. So as we know 2S is equal to 10. So S would be 10 by 2. That would be 5. So we can say that S would be 5 and S root 3 would be 5 under root 3. And hence we can find the perimeter. That would be 10 plus 5 plus 5 under root 3. That would be 23.6. So always this is your shortcut method. This will help you to save some time in the examination. So please remember that if a right triangle is given and uh, the angles are 90, 30, and 60, then the opposite to 30 would be S, opposite to 90 would be 2S, and opposite to 60 would be S root 3. Similarly, there is one more case here. that if this is 90 degree and this is 45 and this is 45, then both are S. Opposite sides of 45 degree would be S, and this would be opposite to 90 degree would be S root 2. So you have to remember both these things. It will come handy while solving exams, solving questions in your exam, because it will save some time, few more seconds in exam. Now moving to the next question. In the triangle, value of cos x is 0.8. Cos x is this cos x is 0.8. If length of AC is 20, so this whole length AC is 20. What is the length of BD? So we have to find this BD. So in triangle, let's say take in triangle A, B, C, in this triangle A, B, C, and we take this one as a right triangle here, this one as a right triangle here. So cos x is 0, cos, so ka toa. So that would be, so ka toa, that would be adjacent by hypotenuse. So this would be adjacent by hypotenuse. So cos, as in the question, cos x is 0.8, adjacent is BC, and hypotenuse is AB. Sorry, AC. Hypotenuse. This is your, so this is your opposite. This is your, from this, for this angle, this is your opposite AB. This is your adjacent BC is, and this one would be your hypotenuse. So a hypotenuse AC. So we can say that 0.8 is equal by 20 BC. Hence we can say that BC is 20 into 0.8, that would be 16. So BC is 16. So by using Pythagoras theorem, we can find AB. So AB would be under root hypotenuse square, that would be AC square, 20 square, that would be 400, minus uh, 16 BC, that would be 16 square, that would be 16 square is 256. So it would be 4, 4, 4, and 1. So it would be 12. Hence AB is 12. So as we can see, there are two types of right triangles are forming. One is like this, and one is like this. So, and as we know, one has right angle here and one has right angle here. And as we know, these two area of both the triangles would be same. So let's take the area of this triangle. So area of this triangle would be half into base into height. That would be, base would be AB, 12 into 16, half into base into height. As we know, the area of right triangle is half into base into height. Similarly, for this triangle, this type of right triangle, base is this and this is your height. So half into base is AC, that is 20, and height is BD. So this will go here, hence BD would be 12 into 16 by 20. So 4 times 5 times. So this one would be 48 by 5. So uh, as we know, 5 10 times is 50. So it is 48. So something slightly less than 10. So as we can see, option is 9.6 here. that is slightly less than 10. So this is going to be a answer. So you can save, you can use this trick to save some few seconds which you will spend on typing those numbers on calculator. See if there were one more option like 9.8 and 9.6, then you have, then if the options are close, then go for calculator. But if options are far away like this, 9.6, 12.4, 16, 8, then go something that is close, that is slightly less than 10, that is 9.6. So this is going to be a answer. Now moving to the next question. In the right triangle a sorry, no, it's not a right triangle, it's a triangle. Angle A is 3x plus 20, B is x minus 10. If sine A, if sine, if sorry, if cos A is equal to sine B, what is the value of x? As we have read, cos A is equal to sine B. That means the triangle is a right triangle, and sum of angle A and angle B would be 90 degree. We have read that in basics. So this one would be 90 degree, and the sum of these two angles would be 90 degree. So angle A plus angle B is 90 degree. We, we have read that in the basics. You have to remember this. So angle A is 3x plus 20, and angle B is x minus 10. So this would be 4x plus 10 is 90. So 4x would be 90 minus 10, that would be 80. Hence x would be 80 divided by 4, that would be 20. So this is going to be your answer, 20. So value of x is 20. Now moving to the next question. In the triangle, length of AB is 20. AB is 20. So what is the area of triangle ABC? As we know, as we have read in the basics, this is 30 degree, this is 60 degree, and then this one would be 90 degree. So we know that opposite to this would be how much? S. Opposite to 90 degree is 2s, and opposite to 60 is s root 2. So as we know, 2s is 20, so s would be 20 by 2, that would be 10. So s is 10, so BC would be 10, and AC would be 10 root 2. So we have to find what is the area of triangle. So so this is hypotenuse, this is base, and this is height. You can understand from this figure. This is C here. If you can if you reverse the diagram like this, sorry, this is B and this is A. 30, 60, and 90. So this is your base, that is 10. Sorry, this is your, sorry, the CA is 10 root 2, and this is 20. So as we know, area of right triangle ABC is half into base CA, that is 10 root 2 into height, that is BC, into 10. So this will go 5 times. So this would be 50 under root 2. Sorry, I made a mistake here. This one would be S root 3. Sorry, I made a mistake here. This one would be opposite to 60 is S under root 3. So this one would be 10 root 3. Let me check. I made the same mistake in previous question or not. No, here I have said S root 3. Okay. I made a mistake here. Kindly correct it. So opposite to 30 would be S, opposite to 90 would be 2S, and opposite to 60 would be S root 3. So this one would be 50 root 3. So this is going to be a correct answer. Now moving to the next question. In the rectangle, tan angle BAP. So this angle, tan angle BAP is 1 by 3. So as we know, SOHCAHTOA, so tan angle BAP is opposite. So opposite to this angle is BP. BP by adjacent. So adjacent is AB. So from this we can say that, as we know, tan angle BAP is 1 by 3. So BP by AB is 1 and 3. So BP would be 1 and this would be 3. Similarly, tan angle CDP. So TOA, that would be, so tan angle CDP. So TOA, that means opposite. Opposite is PC by adjacent, that is CD. So PC by CD, in the question it is given 2 by 5. So PC is 2 and this is 5. As we know that, see, they are in proportion of 2 is to 5, and this one is, this triangle, these two sides are in proportion 1 is to 3. As we know that in rectangles, these two sides would be equal. And similarly, the AD and BC would be equal, and AB and DC would be equal. So how we can make both of them equal, in equal proportion? We have read this concept in ratio and proportion chapter. So what we're gonna do this, we will multiply the, the ratio of this triangle into 5 and this triangle into 3. Now we can see that both of them are 15, and similarly this is also 15, and BP is, because this is a concept of ratio and proportion, so we have to equate both these two sides are equal. So we, for equating them, we have multiplied this triangle, sides of this triangle into 5 and sides of these triangles into 3. So this is going to be 6 and this is going to be 5. So in question we have to find what is the value of BP by CP. So BP would be 5 and CP is 6. So our answer would be 5 by 6. The next question, in the rectangle, F and E are midpoint. This is your midpoint. This is your midpoint. And E is also midpoint of CD and BC respectively. So these 2 points are midpoint. If value of sine angle BAE is, so sine SOHCAHTOA, sine angle BAE, that would be BAE, that would be opposite of this angle is BE, and hypotenuse is how much? Hypotenuse is hypotenuse is AE, opposite and hypotenuse. So we can write this 0.6 as 6 by 10. AE. If we can further divide it, 3 by 5. So they are in ratio. BE is 3 and this one is 5. So using Pythagoras theorem, we can find AB in triangle ABE, we can find AB by using Pythagoras theorem. So AB would be hypotenuse square, that would be A 25, 5 square, that would be 25, and minus this one, B square, that would be 9. So it would be under root 16. So AB is how much? 4. So AB is 4. As we know, this is the midpoint, so DC would be also 4. So DF would be 2 and 2. As we know, whole thing would be 4. Similarly, E is the midpoint, so BE would be equal to EC. So if B is 3, then EC would be also equal to 3. So we have to find what is the value of tan angle ECF. EFC. So tan angle EFC. So SOHCAHTOA. So that would be opposite by adjacent. So the opposite is 3, adjacent is 2. So tan angle EFC is 3 by 2. So this is your answer. Excuse me. Now moving to the next question. In the figure, sine A is equal to cos B, as we have read in the basics. So this is a right triangle, and angle A plus angle B would be 90 degree. So this is 90 degree, and sum of these two angles would be 90 degree. So we have to find which of the following is not true. So C is equal to 90 degree, as we know. So this is correct. Now, as we know, angle A plus B is 90 degree. So we can also write that angle B is equal to 90 minus angle A. So this is also true. As we know that angle A plus angle B is 90 degree. So this is also true, but this is not true. So this is going to angle A is not, can never be 90 degree. Angle A plus angle B, sum of both the angles would be 90 degree, but alone it cannot be 90 degree. So this is your answer. Option D is your answer. Now moving to the next question. In the triangle, cos A is equal to sine B. Cos A is equal to sine B. So this angle would be 90 degree, and sum of these two angles would be 90 degree. So if length of AB is 20, so AB is 20, and angle B is pi by 3 radian. So if we convert it into degree, that would be 180 degree by 3. So this is 60 degree. So angle B is 60 degree, and this is 90 degree. Hence this one would be 30 degree. So opposite to 30 is how much? S. Opposite to 90 degree is 2S, and opposite to 60 degree is S root 3. So now you can simply find the area. So as we know, AB is 20, so 2S is 20. 2S is equal to 20, and S would be 20 by 2. That would be 10. So, so S SCB is equal to S. So this one would be equal to 10, and this one would be equal to S root 3. So 10 root 3. So what is the area of triangle? So area of triangle is half into base into height. So base is AC, 10 root 3, and height is BC, that is 10, and this is your hypotenuse. So 5 times, so this would be 50 root. So this is going to be your answer. Question number 10. Now moving to the next question. In right triangle ABC, in right triangle ABC, AD is 10, AD is AD is 10, BC is 25, BC is 25. If the value of sine angle BCD, sine angle BCD, so katoa, so the sine angle BCD, that would be opposite. So if we take in triangle ABC, and this is your, so opposite, so opposite by hypotenuse. So AB by hypotenuse BC. So we know the value of BC is 25, and from the question, sine of angle BCD is 0.6. So AB by 25. So we can say that AB is equal to 25 into 0.6. Let me calculate on the calculator. This is going to be 15. AB is 15. AB is 15. So we can find AC using Pythagoras theorem. AC would be BC square, that would be 25 square, 625 minus BA square, BA square, that 15 square. So that would be 225. So that would be root 400. Hence AC would be 20. So if AD is 10, so this whole thing would be 20. So so we have to find what is the area of triangle ABC. So area would of right triangle ABC is area of triangle ABC would be half into base. AC is the base 20 and BA is the height. So half into base into height. So 10 times. So your answer would be 15 into 10, 150. So your option D would be the correct answer. Now in this question, in the figure, angle ADB, angle ADB. So this angle is 60 degree. Angle ACD. So this angle is 30 degree. And CD is 10 root 3. So this is 10 root 3. What is the length of AB? So we have to find what is AB, this length. So first we will take this smaller triangle, triangle ABD, this smaller triangle ABD. So as we know, this one is 90 degree, this one is 60 degree. So this is going to be this only here between would be 30 degree. Now let's take the larger triangle. Okay, larger triangle, angle ABC. This is a larger triangle, this whole big triangle. So if this is 90 degree and this is 30 degree, as we know, sum of all the angles are 180 degree. So this one would be how much? 60 degree. This whole angle from here to here would be 60 degree. And similarly, if this is 30, so this angle would be angle DAC. Angle DAC would be 30. As we know, angle BAC is 60, and we already found angle BAD is 30. So this one would be 60 minus 30. Hence, angle DAC would be 30 degree. So if you take this triangle, so in triangle ADC, this angle is 30 degree and this angle is also 30 degree. As we have read in triangles chapter, e- sides opposite to equals angles are always same. So if this is 30 degree and opposite side is 10 root 3, similarly this is also 30 degrees, so this one would be also 10 root 3. So in, we can say that AD is 10 root 3 because it is side opposite to equal angle. This is the property of triangle. We have read that in triangles chapter. If both the angles are similar, then there's opposite side would be also similar. So if this is 30, this is 30. So their opposite side is already given 10 root 3. Similarly, this is 30, this is also 30. So opposite side would be AD would be 10 root 3. So this is now in, now let's take this triangle. Triangle ABD. This is a tough question that was asked few years back. The level 3, level 4 question. And this is 30 degree. If you take the smaller triangle ABD, and this is 30. And we have already found CD is how much? 10, sorry, AD is how much? 10 root 3. So as we know, we have read in the basics, if a triangle has 90, 60, and 30, so opposite to 30 would be S, opposite to 90 would be 2S, and opposite to 60 would be S under root 3. So AD is 2S, so 2S is equal to 10 under root 3. So S can be written as 10 divided by 2, that would be 5 root 3. So we can say that BD is 5 under root 3 and AB is AB BD. So we can say that BD is equal to S. So that is 5 under root 3 and AB is equal to S under root 3. So 5 under root 3 root 3. So that would be 15. So BD is 5 under root 3, AB is 15. So we have to find what is the length of AB. So AB is equal to 15. This is your answer. So this is the end of this part 1. In part 2, we are going to solve few more questions, 10, 8, 10 more questions, and they are of very high level. So do watch part 2. Thank you.
If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, you can download our app from the App Store and start your self-paced preparation from pre-recorded videos provided in the course. My course also includes chapter-wise practice questions along with 20 test series at par with SAT exam. You can find all the links in the description below. Now let's move to the next question.